again, we're not going to create a table of values. We're just going to graph y equals log 2 of x. Okay? And then we're going to graph this one with transformations. So, on the left here, I'm going to graph y equals log base 2 of x. Every log graph goes through 1, 0. Every basic log graph goes through its base, comma 1, and there's its basic shape with an asymptote at x equals 0. This is the parent graph. Can you recognize the parent graph here? That this also has a base 2 connected to this graph. Okay? In exponential graphs, we actually took out a highlighter and we highlighted right? I just highlighted the base graph in my equation so that I could see what new things are there. There's a new 2. Wow, that's yellow. Can you see that that 2 is inside where the x was? And it's going to be a horizontal compression. The minus 1 is after. Sometimes you'll have brackets here to really show that it's only the 2x that's inside the logarithms. So this 1 is going to be a vertical translation. We're going to go 1 down. So what did we do in chapter 3? We took points from our original graph, which were 1, 0, and 2, 1. We did all of our stretches and compressions first, and then translations second. We also looked at what's going to happen to our asymptote. So according to this, you will have to multiply your x by a half. Remember, x's are liars. And then go 1 down. So if I multiply x by half, I'm going to get 1 half, 0, and 1, 1. Then if I go 1 down, I'm going to have 1 half, negative 1, and 1, 0. My asymptote, which is at x equals 0. Does it make sense that all the multiplying is not going to change it because it's at 0? The only thing that's going to change your asymptote is if you move it left or right. This time we're moving it down, so our asymptote stays at x equals 0. So I can sketch a new grid, add my asymptote at x equals 0. I have the point 1, 0, and I have a half and negative 1. And I draw my graph through those points, and that is my new graph based on my old graph. We take the 2 points that we know, we do our transformations from chapter 3. Okay? And then it says, I'll answer part C, and then we'll go from there. Identify the intercept. So the intercept, we only have the x-intercept at 1, 0. The asymptote is still x equals 0. Domain and range of this new graph, x is greater than 0. Range is that question.
I heard there was a horizontal translation. Where would it be? Like in the equation? If there was a
if there was a horizontal translation, so I'll write it in, let's say you had bracket x minus 2 here, right? That's inside the function, that would be 2 to the right, and then you would have 2 to the right here. So I remember everything that's horizontal always happens where the x was. So the only thing that's inside the box right now is a 2x, so we only had a horizontal compression. So we're going to do a couple of more examples. I think you have space on page 400. Do you want to try them on your own first? And then I'll put up, if you want to try them on your own, you want to grab a scrap paper, and if you don't want to like wreck your beautiful book, you can do that. All right, do a little check. First of all, recognize that the base graph, the parent graph, is log base 3 of x. So I do a little sketch off to the side of that graph. And then I go through my numbers and I'm like, okay, I have a vertical stretch, a horizontal translation, and a vertical translation. So I set up my points, do my stretches first, then translation second. This time my asymptote is going to change, because I'm going 1 to the left. Then I can take my new points and my new asymptote, label the 2 points, label the asymptote, draw your logarithmic graph through those 2 points towards the asymptote. The second example, notice you have a horizontal stretch and a horizontal translation. So you have to remember to first put it in factored form. Remember that from chapter 3? Your base graph, the natural log of x, has the point e comma 1. And see where your points end up. And then you can graph your final graph.